Okay, so do you have any question in this class? Let me know. So. Do you have any question?
I'm sure I'll find some questions when I do the homework.
Okay. Okay, so let's review about what we learned on Tuesday. Basically, this is everything about the object-oriented programming. So basically, for the object-oriented programming, you have the 4 characteristics, right? You have, what are they? What do you think? You have a 4 characteristics of the object-oriented program.
Encapsulation.
Yeah, encapsulation. That means you include every attribute and method in the one single object, right? So that you reduce the interdependence between the function when you call them. Because when we call the function, you have to passing the value from the argument into the parameter, right? If something change in the function or something change in the parameter, you have huge problem here. So we have encapsulation. You have what else? Abstraction, right? Abstraction, that means you can hide something. So basically, when you work with the object oriented, you can hide some of the attribute, or you can hide some of the method. And you know that whenever you want to hide, you can put attribute and method with a double underscore, right? And you have inheritance. Later on, we learn about what is the inheritance, and you also have the formalism. Right? So yeah, that is something about the object-oriented. You have the basically for every object, normally you have attribute. You can think about it is a parameter, and you have the method. You can think about it the function here. And it's also you can also use a private method here. Private method, everything you put it right. You put it here. You put it here. I mentioned it. Okay. So we learn about the class and instance here, right? So the class is a where you have the code and you have to define the object. And when you have the class, you can generate multiple instances you want. Right? You can think about it is a case of the cookie cutter here. You can think about cookie cutter. It is a class, and you are the one who made the cookie cutter, right? And from the cookie cutter here, you can generate a multiple cookie by the cookie cutter. So you can think about this one thing. And you can think about, to make it simple, you can think about this is a class. You are the one who code it. You are the one who made it, right? So when you have the cookie cutter already, you can generate the multiple cookie. They are instant, right? So now hope you to understand between the difference between the class and instance here. Okay, so the class definition is that you use, it's very simple here. You use a class and the class name here. Class is a syntax here. Right? The class is a syntax and class name is just your choice. You can put whatever it is. And remember that for every class definition, normally you have the cell parameter here. Sorry, you have the cell parameter. It's required. It's required in every method in the class. It's a reference to the specific object you are working with here. Okay, and normally for every class you have initialize method. Remember that when you have the initialize method, it will automatically execute whenever you generate instance. So whenever you generate instance, it is the first method you need to be execute whenever it is here. And if the format is here, the format is also very simple. You have the definition, you have the underscore here, double underscore, and you have cell here. That it tells you are working with the instance. And in some case, you also have the sum parameter here. It's up to you, right? Okay, so here you come back with a class definition. Is that you create a class with the name the coin. You see, you have the first thing is have initialize method here, right? And in that one, you only have one parameter, is the self only. And you see in the parameter here, you set the sign up here. You set the sign up. It's a head sign up here. It is the attribute of the class. And also you define some of the method here. Also, it can be head or tail. And so you have the method to get the sign to print out it's a head or tail here. So basically, you see when you work with this class here, when you work with this class, you only have one parameter. It's a self only. It's a self only. But in some of the other case, you can have many parameter when you define with the initialize method here. So when we define the class, you can use the class to generate instant here. Right? You can use a class to generate instant here. So think about this one here, right? You have you use my coin equal to the coin here. That means what is that? That means you generate the instant with the name of my coin, right? It's from the class of coin. And of course, when you generate the instant, it will inherit every method and every attribute from the class here. That's why you see you can use a toss method here, and you can use the get size up method here also, right? Okay, so remember that whenever you generate instant here, whenever you generate instant here, the first method it always will be automatically generated. Right? Automatically execute. It is initialize method here. Right? So that's why at the beginning, whenever you create any instant from the coin, all of them is in the head state at the beginning here. Okay, and again, you can separate the class and you can store it into the module. And whenever we run the program, you can import that module, right? So when you import that module, you can use any attribute or any method of that one here. Okay, see the class also has a multiple parameter in addition to the cell, right? So if you go back to the last example, you only have one parameter, the cell. But in some of the case, you can have more than one parameter. Think about this one here. If you define a bank account class and you have the initialize method here. So in that case here, you see, in that case, you not only about the one parameter self, but also you have the balance. Balance is the current balance of the account here. And also for this one, right? You have the deposit, you have amount, you have the withdraw, you have amount, and so on here. And so we mentioned about the string method. String method is a string method is that whenever you use it with the print function here, whenever you use the print function and the parameter so think about whenever you use a print function and parameter it is instant here. It always print it out. What is it? It's always print out. What is the status of the instant, right? So think about in the case of the coin, you have status the coin only head or tail, it's head or tail. But in the case of the bank account, right, the status of the bank account is the current balance, right? So basically, you can define the string method here, and you can use this combination when you use the print function here. So that's the example you can see for that one here, right? When you define where I define here, this one here, I define it here. I define the string method here, right? So in the string method, it always returns to the status of the bank account. It's a balance, right? So that's why whenever I use it here, whenever I use the print function and the name is instant here, it will print it out. What is the balance of the instant here? Make sense? Okay. Okay, so when working the instant, that means you work with the class and with the class and you generate instant here. So basically from the one class, you see from one class here, you can generate from multiple instance. It's totally the deal, right? You only need to code it one, but you can generate it multiple letter here. And for whenever working instant for each of the method, it associated with a single with a specific instant. You see, get sign up here, it associated with the instant coin number 1, and get sign up here, it is associated with the instant coin number 2 here, so on. And so we learn about the accessor and mutator. Accessor method is that when you access it into the attribute of the instant, but you take it out without changing it. And the mutator is when you take it out and you do something about modification of the data you want it here. Okay, now I think yes. So I think that's all everything about the definition of the class instant, how to create a class, and how to work with some of the initialize method or work with the string method here. Now we have the some of the specific example. We have the some of the specific example when work with the class instant here. In that you have the data modeling here. Data modeling, you can think about one specific example when we work the rational number. Rational number, it is a number that consists of 2 integer parts, right? You have the numerator and you have the denominator. I think about we have 1/2 or 3/3. Sorry, 2/3 here. So basically in the Python, they have it have no built-in type for the rational number. So it is your responsibility to build a class with the name the rational here. So think about I only have the class. I only have the class with the name sorry, I only have the class with the name is the rational, and I store it into the file rational here. So when from rational file, I import everything. Here. Right? So for this one, I have my first number. I have the rational. Or remember, in the class of rational, for a class, you have the 2 attributes. It is a numerator and it is the denominator here. Right? And from this one, you have to simplify it. The purpose of this one, you have to simplify it here. So think about you have the 20 over 15, and we will simplify it into the 4/3 here. All right? And the way you simplify it, you have to use a common
denominator.
No. You have the common greatest divisor, right?
Oh, greatest common factor.
Yeah. Okay. Okay, so now see how it works with this one here. So how it works with this one, and how can you work with the simplify here? So basically for this one here, in order to simplify the rational number, right, you use the greatest common divisor here. The greatest common divisor of the 2 positive A and B, that is an algorithm to find out what is the greatest common divisor. So basically, whenever you have the 2 integer number, right, and you want to find out what is the greatest common divisor, you compute the remainder of the dividing the larger number by the smaller number. So we can think about, you come back to this one here. If you come back to this example here. So if you want to find out what is a greatest common divisor of 20 and 15 here. So how we find out? You have to divide it, right? You take the larger number, you divide by the smaller number. So in that case, what's the remainder of that one? The 20 you divide by 15. What's the remainder here? 5, right? You have a 5. So we have a remainder of 5. So again, when you have a remainder of 5, now you change this one. This one now is a larger. This one's a larger here. And this one is smaller, right? And again, you divide this one. So when you have 15 divided by 5, you have 0 in the remainder. In that case, you take the smaller one as the greatest common. Greatest common divisor here. All right. So that is the way you work. How we'll find out the greatest common divisor. So we think about this one here. You can think about in the case I give you the example here. Think about in the case if you have the 60 and 100 here. What do you think? What is the greatest common divisor? If you find out from the 60 and 100, 20, right? The 20, yes, of course, you can see it clearly. But from the computer point of view, we have the offset here, right? Again, you take the larger one, you divide by the smaller one, right? You have the 40. It is a remainder, right? It's the 40 here is a remainder. So now again, Z is the larger one and Z is the smaller one, right? So again, you take the 60, you divide by 40, right? You have the 20 here, remainder, right? 20 here is remainder. Again, Z is the larger one, Z is the smaller one. You have the 40 here, you divide by 20, you have 0, you have no remainder. So in that case, when you come to the 0, you take out the smaller one, it is a greatest common denominator. Right? So the process here do the same. The process here you do the same, right? I have A, I got the first positive number. I have the B here. I have the second positive number, right? So now the first step, I have to find out which is a larger one and which is smaller one, right? That's why I find out here. The A, I got it from the max, and the B, I got it from the mean, right? Now see, I keep doing it. I keep doing the process until I have remainder is a 0 here. Right? That's why I check. If the B here, you can think about the B is a smaller one. Keep doing it. If B is not equal to 0 yet, so every step I just take the A here. It is I take it A from the smaller one, and B here is the remainder here. That's the process. That's the process here. And basically, you can do every number here. So you can run this process here. This one. Okay, here's the code. Whenever you want to find out what is the greatest common divisor, right? So think about you can run whatever it is. You can run whatever. So in this case, you can think you enter the two number, you have the number 60, and you have 100 here. You find out the 20 here, and or you can think about what about you think about 27 here, and
420.
420. 420. I don't think you have anything in common.
3.
420. Yeah, it's 86 here. 420. Yeah. Okay. So basically, you see, for this one, you have a lot more process. This one, right? You divide. You can chase down by this one here. You can chase down by this one. So basically, you have 27, 420 here. Right. So we can see at the beginning, find out what's the max and what's the mean here, right? So see, the first step you have to find out the max here, therefore, you divide it. Now you have a 15 remainder, right? Remainder. So now we swap it. Now the 27 is A, 15 is the B, right? And divide it. You have what's the remainder here? You have 12 remainder, right? So we swap it. You have the 15 and swap here and so on. Let's whenever you have the 3 and 0 here, that A is a 3, and that is greatest common denominator, right? Okay, so the purpose of this one, the purpose of this step here, the purpose of the first step, when you work with the rational, let me come with the rational here. What do we have in the rational? Okay, so that is the rational, right? The rational, you create a class, it's the name the rational here. And in that case, you have the rational number, you have the two parameters, is the numerator and denominator here, right? So that's why you got it. It's a number here and denominator here. And in that case here, whenever you execute it with the initializer method, you call it out. You call it out the reduce method here. So what the reduce? You see, when you call the reduce here, you have to define the reduce. Reduce here actually is a user find out what is a In the review again, you call it out for the method GCD here, graded common divisor, right? And when you call it again, you have to define here, and that is everything I do with the simulation here. That is the way you find out what is graded common divisor, right? So now we can check it down here. The first thing, whenever you have numerator and numerator, you assign the numerator and you assign numerator here, and you call the review. So what's the review? Review, you call about you find out what the graded common divisor, right? And you divide. You divide both of the numerator and the numerator for the common graded common divisor, right? So basically, you can think about this one here. In the case of, you think about in the case of the you generate a class, you generate an instance with the rational here. Think about in the case you generate instance with a rational here. And you have the 20 and you have 15 here, right? So what happened here? You assign this one, it's a numerator. It assigns this one, it's a denominator, right? That's the first step. The second step here, you call for the reduce. So in the reduce, you have to find out what the graded common denominator. You know that this one, the number 5, right? This one, number 5. So you see, you divide both of the numerator and denominator for the graded common divisor. You divide for 5 here, and you divide for 5 here. So in the end, you have the 4 and then you have 3 here. All right? That's all. That's the process of this one. So now we can scan down here for this one here, right? You have numerator, you got it, you return it from the numerator here. You have the denominator, you return it from the denominator here. And this one here, this one is very helpful in the case you want to print it out, right? So you see, that's why you divide with the string method here. String method is a print it out. You have the string of the numerator and divide by string of the denominator here, right? Okay. And you see the reduce method is very simple. You just call about and to find out what is the graded common divisor, and you divide both of the numerator and the denominator for the divisor. All right. Okay, so basically that's everything about the rational method here. Now we can do it with this one. You can do with this one here, whatever. Okay, so now see what happened in my program here. I import the rational module, right? You see that is everything I define with the class rational here, right? So I import it, I import everything. So see the first thing here, rational here. So whenever you have the rational 25 and 40, actually you use the process. Assign the 25 for the numerator. You assign the 40 for denominator, right? And you have to call the method of reduce. What the reduce? You find out what the graded common divisor, and you divide both of them for the common divisor. That's why you see when I print out my fraction of number 1, what do you have here? When I have the print, what is it? What happened when I had the print and my fraction number 1 here? What do you think? What happened? What happened if I use the print and I use the instant at a parameter here? What happened?
We'll just reduce it, right?
No.
Just it's not rational 20, 25, 40. That's 25.
Now, to understand the process of a print function and instant name, what is it? You have to define for string function. Right? You have to define, yeah. Actually, this action here, it calls out the method of string. Right? You know that, right? So this one here always return about the standard of the instant. Right? That's why you see whenever you have the print here, whenever print here, actually it works with this one here. It works with this one here. Right? It works this one here. Make sense? Okay, and it works this one here. But you see, you have string cell number here. When you have string cell number, right, you have the process of the whenever you initialize it. The first step you have to reduce it, right? So basically after this step, you reduce to the 4/3, right? So when you use the clone function here, when you use the print function here, it prints out.
To reduce.
This one is the 5. Oh no, this one 25 or 40. What is it? 5 over 8. Right? The 5 over 8 here. Make sense? So again, I just want you to remember about when you use the print function and the instant name here. It turns it out the status of the instant. Right? And whenever you turn it out is status of instant here, it call it out the method, string method. Right? It call it out string method here. And if you see in the string method here, you define, you have string of the self name, and you see you have the symbol of divide here, right? Division here. Right? So you see when you run this program here, when you run this program, right? You have the 5 over 8, and it's also 5 over 8. Okay, and I will explain this later. But for now, that you see, that is the process. That's the process that you create instant with the numerator and denominator, and you reduce it, right? You just simplify it, and later on you just print it out. What is the simplify here? So we have the 5 over 8 and 5 over 8 here. Okay, makes sense. Now, so far we define about the rational number. Right? You have the numerator and you have the denominator. You define how to reduce it, how to simplify it, and you define how to print it out. Right? So now you also need to sum up the method that you want to do with the addition, right? Subtraction, and the comparison together. If they are equal or not, or they less than or not, or greater than or not. Right? So in order to do that, you work with the arithmetic and operator overloading here. So basically, you see when you have the operator add here, right? When you want to add together, that is matching with the method with the name add here, and you have the minus is matching with the method sub here, the subtraction, and you have multiplication, you have mod here, and you have division, here, and you have modular. That means you have the remainder here, right? So that you have the modular here. So in that case, you see what happened here. What happened here? You see they are matching together, right? I have, whenever I use the operator adding here, I have to define. Now I have to define with the name of the method add here, with the add here. So what happened here? I define the add with the self and the other. Self, that means I have one rational number, right? And I add it to other one here. So we see whenever you want to add the two rational number, what you have to do? What do you think? What you have to do if you want to add the two rational number together? Think about this one here. Let me do it here. Why? Think about this one. So think about if I want to add 1 over 2 plus 2 over 3, what I have to do?
The denominators have to be the same. And
yeah, you have to make it common denominator, right? You have to make it common denominator. And the easiest way is that time this rational with the denominator here, right? And you time this rational with the denominator here, right? Yep. So think about this one here. So 1 over 2 here, right? You time with the denominator of this one. You time both of numerator to 3 and denominator to 3 here, right? And you do the same, and you have the same number, right? You see, you have the same number here. So we have 3 over 6 here, right? And this one also, for 2 over 3 here, you time both of numerator and denominator with the denominator, the other guy here, right? So we see you time it to the number 2 here, and you time it to the number 2 here. So you have 4 over 6, right? So you see, they have the same denominator here, right? So now the last step is to add the numerator together, and you keep the same denominator, right? So in the end, you have the 7 over 6 here, right? So basically that's the process when you add the two rational number together. You have to find out what is the common denominator. And the easiest way is that time it together. You have the same common denominator here. Oh my.
Whoops.
Why?
I think you accidentally clicked it.
Okay, so see, I do the same. I do the same with the process here. I do the same with the process here, right? You see, I have cell number. Remember the cell here, it is object rational, right? That's why you have the two attribute, numerator and denominator here. Right? So see, I have the cell number here, numerator. You time it to other denominator, right? And so I add it to the other numerator. I time it to myself denominator. That is a new numerator here, right? And of course, the new denominator is the time the two denominator together. Right? I said. So what happened here? See, you return it here. You return it rational and new numerator and new denominator here. And of course, when you return this one, you have the process of the simplify and you have the process of the reduce already. Right? Okay. So that's why you see. That's why in the case here. That's why in the case I modify the program here. Think about. And remember one thing here. You only have to define the function with the add here, matching with the operator. That you only have to define the matching. Okay, so here's the process. That's the process of the addition, and you can do the same. You can do the same with the other one here. So think about the case of subtraction again. Subtraction also you have to make this the same common denominator. Yeah, sorry. Yeah, the same common denominator here, right? But in that case, you just subtract it together. And multiplication, you time numerator to the numerator and time the denominator to the denominator. And the division, you time the division. You just take it numerator divide by. Actually, you have numerator of the number one. You time with the denominator of the number two, and so on. So now you think about what's this one here. If you look on the program here. If you look on the program, here's the way I define the addition. So now, if I require you to do the method for subtraction, for multiplication, for division, and modulation. Modulus here. How can you do it? Can you do it? You can follow the same process here, right? You can follow the same process here. That is when I define for the add method here. Now, if you want to define for the if you want to define for the subtraction method,
it's the same.
Yeah.
You gotta subtract that from wherever it is. So you copy the same thing and then instead of add, you subtract.
Yeah. So it's the add here, right? So add here. It's the add, right? It's the add method here. Now, if you want to define for the subtraction here, I don't know if I have the subtraction. Oh yes, here, right? So do the same, but remember here, the name you have to change it to the sub here, right? Because it's matching with the subtraction here. And again, you have the number. Why have to use the absolute here? Absolute.
Because at some.
Oh, you have. No, sometimes it can be the negative, right?
Mm-hmm.
It can be negative. Why have to use the absolute here? Let's see. Let's see with this one here. Let's see with this one. What happened here? Think about, yeah. I change this one. It's think about I have 12 over 20 here, and this one bigger. To see what happened here. I have 40 over 30. So what happened? What happened with this one?
4/3.
Oh, sorry, I have not printed out
Yeah,
sub yet. Sum print sub. The thing is that it should not. I think it's not correct. You do not have to do this, right? Because it can be negative here. Okay. So we run it again. Yes. Why?
-1 over +1.
Oh, so
What's wrong with this one? Now find out what's wrong with this one here. Okay, now go back to this one. You have the cell numerator times other denominator, is correct. Minus other numerator times. Wrong with this one. Now find out what's wrong with this one. Now let's see. Let's see if I put it absolute again. Let's see if I put it absolute again. Let's see what happened here. Right, so I expect that it returns the -7/12, right? I expect it returns -7/12. If I delete the absolute here. But why it return -1/1?
oh wait, hold on. Isn't it because of the reduce itself? That could be the problem.
I think here because it is asked you have -7/12. Let's see. If you have -7/12 here, right? No, see. Now let's do it again. Let's do it again with the original one here. Let's do it again with original one here for this one, right? So for this one, you will have you would have
3/4 and then 4/3.
and you minus 4/3 here, right? Right. So you have the 12 in common, right? So you have this one here. You have 9/12, and you minus then you have the 16/12, right? So we have -7/12. Is what you expected here, right? That's what you expected here. That's what you expected. Is correct. It's -7/12. But why when I change it, it is -1/1? Yes. So see what happened. What happened with the? But I think the reduce are correct. Right? The reduce are correct here.
It may think that I can
The reduce here. The reduce here correct. The reduce here correct. Reduce here is already correct. But what happened?
It may still think that since there's a negative, that 12 can swap for the max.
Let's see. Question.
That's an interesting point, though, because when we put it into rational, technically the top part is going to be -7, and the bottom part, the new.
Oh, I see one thing here.
So that means it's going to forcefully look for the minimum. Good catch.
Yeah, that's why you had the absolute in order to stop it from doing that, in order to make the 7 positive. This thing cannot handle negative numbers. It was never designed to handle negative numbers.
I mean, you can always put a condition on like putting.
Yeah, you can check. Right? You can check the condition. Yeah,
you can just put in a minus or negative whatever at the end if you want.
Yeah. Okay, I understand what you mean. So I think it's
due to the fact that
if you do the absolute, right, and later on you can check if the first number greater than, also we can flip it. Yes, it works also, but yeah,
it's doing as it's supposed to.
Okay.
It's just that it keeps flipping the positions over. Eventually speaking, you keep dividing. Well, you'll eventually reach 1. There's no point.
Or anything. They just give you whatever's negative and just split it, because The condition was minimum and maximum.
Now you see if you have the negative.
Would it even run? Because it should technically just die.
Now you see for this one it is negative. Sorry, this one you have the -7, and you have the 12 here, right? So what happened here? This one is a bigger, right? So that you have 12 divided by -7.
But it says while, but the condition for that is while B
right.
it's greater than 0. So that means it should die there.
Yeah, that's the problem. Yeah, that's the problem here. That's the problem. This one already
condition.
This one already less than 0, right? That's why it never worked for this one here. Yeah, that's a good catch. So see, if you go back to the definition of the greatest common divisor here, you see if you go to the definition of greatest common divisor, where here you can come. Oh,
you have to exit out the drawing.
Here. See, where greatest. Yeah, see, you have y b greater than 0 here.
So it should,
but yeah, it never ever execute for this one because you see -7.
A became
so that's why
less than 0.
Yeah, that's the thing. That's the thing here. That's the thing. That's the thing. That's the thing. That's why. Yeah.
That's why the absolute was there.
So basically, this one only work with the positive number.
Well, you can also put an absolute for the min, and then force for it because it's not going to return.
Yeah, I know. I understand that. Yeah, I can put the absolute here, right?
Yep.
But okay, but later on you have to check and you have to flip it, huh? You have to flip it.
Mm-hmm. Well, it will check because like you'll put in -7 and 12, and then we forcefully reverse it, saying that 12 is the max and then -7 is the minimum. But if we put an absolute value after that, you'll have 12 and 7 to check around with. Now that's not going to really work.
Now see what happened here.
That won't work if you're
now see what happened with this one. Now see what happened with this one. I do with negative here. Huh? I do with negative here.
Mm-hmm.
So it's wrong here, right? It's wrong here. Okay, now come back to this one. I modify this one. Where this one? Put the absolute here, right?
I don't think this will actually fix it though, because what if they check it and say you have what if you put a fraction that's like -400 over 3? Because that means you're going to look at -400 being the minimum, but then it's going to be absolute value.
Yeah.
So that's also not a fix.
Well, is it? Need to check our endpoint. Oh boy. What if there's an
actually, and for this one, you have many ways to do that. You can do it. You can do it here. So you can think about you can have you can do the selection here. If I times B greater than this.
Wait, so let's pretend that -400, like let's do -400 over 10, because then 10 would be the max, and then we forcefully change the minimum to 40, from -40 to 40, because then while B is greater than 0, so 40 is greater than 0, we return B, and then the absolute, and then check for A mod 40, which gives us 10. And then we now we switch the position, so it's 40 over 10. No, it should work. If we put an absolute value, maybe before min, it should work, right?
This one? Was this one?
Uh-huh. I'm thinking it should work.
I don't think so. No. Anyway, let's see here.
Yeah, there's only one way to find out. Just run it and see what the.
Okay. Oh.
Hey.
No. What happened here?
Oh no, the subtraction failed.
Yeah. That's the thing. Yeah.
So the summation and the subtraction are completely different.
Yeah, that's why
that's
why you have to check. That's why you have to check. What is it? Where?
I mean, technically, if you did the opposite.
No, that's why you have to check it. The first step is to check if it's negative number or positive number or not, right? So after that, it's negative number. You flip it, right? Okay.
If A is negative.
Yeah, you flip it. After this step, you flip it. Okay. Anyway,
it would be if A times B is negative, because you want to check to see if either one of those is negative.
Yeah. So if you just times them together, if one of them is negative, the result will be negative.
Yeah, right.
Now you figure it out from there.
That's what I meant.
Yeah.
Yeah.
All right, let's try that.
Yeah, let's try it here. So think about it at the beginning, right? At the beginning here, you have if I times B greater than 0.
Then you run all that.
Yeah, I run all that here. Cool. If not, I flip it, right?
Mm-hmm.
Yeah. Else. Return. Negative, right?
If that's going to be the condition, I would say, because it would just immediately return A if in this condition.
Now we gotta copy and paste some stuff real quick.
It's not that it wouldn't be the greatest common divisor at that point.
Let's see.
Because if you put in -10 and like 15, because that is going, because you get a product that is negative, it immediately turn in 15, but -15 and 20 wouldn't really give you a greatest common divisor.
Yeah.
So
okay. Yeah.
So in this case, because like it just returns -A, you would have to. I don't really want to copy paste it because it's bad. Well, okay, so we can check for the minimum and maximum, and that'll give us let's look at a positive and a negative at least. What's that one? Either a positive or a negative. That doesn't matter. So then if we check the product of those two, how do we deal with it? If it's positive, then we leave it alone. If it's negative,
okay. Anyway, you can talk about that later. You can try to manipulate it. Anyway, for now, it should be better. I do not use the negative here.
For now.
Now it does not seem capable of handling.
Or
absolutely, you can do it. I will find out. But I do not think I will have to spend a lot of time this one.
You also can't make one of the numbers, the first number smaller than the second number in this case. Because when you did 3/4 minus 4/3 with the current one, that's how you got positive 7/8 or 7/12. For now.
Okay, anyway, let me come back to the slide here. All right, so basically you can define whatever method it is, right? So based on the operator and the method name. But remember that you have to matching them, right? So see when you want to add them together, you use the add here, right? When you subtract here, you use the subtract and multiplication and division and modulation. The thing about in the case, if you want to do with the multiplication here, right? You can divide it here. You can divide the same. You can divide the same for this one. Now, what do you do? What do you do here? What do you do here? What is the new numerator? Numerator is You just time them together, right? That's why you just sales number time other numerator here. Oh no, no. Number. Okay. That's all, right? That's all. Yeah. And new D below is a cell. Other D now here.
Yeah.
Okay. Okay, now run this one. Let's see what I time them together. Okay. Okay, why 101 here?
That is correct, because you have 3/4.
Okay, yeah.
And so that would be 7/7.
10. Yes. Okay. Okay, so we do the same. You can do exactly the same with the other one here. You can define for what's the division and what's the modular here. Right? So in that case, you have the division, you have this one. Okay, that is the way you work with the data modeling. That is example of data modeling. And you see for data modeling also you can work with anything with the you can compare equal or not equal, less than or equal, greater than or equal. And the method name here. You can use the method name here. Right? So you can define whatever it is. Now we go with some of the other example when you do with the sum of the example here. I think about we have the saving account and class variable here. So think about we have the saving account, right? In the case of the saving account, I have the coding here for the saving account. Saving account, I define the class with the name of the saving account. In that, I have the global constant here. Global constant. It is a 0.02% for a single rate for all account, right? So in that case, for the saving account here, I have the 1, 2, 3. I have the 3 parameter. With that, you have the name, right? For name is the username. You have the PIN number and the balance. So balance at the beginning, you can see I can set it everything 0 here. Sorry, at the beginning you have the 0 here. Right now, I want that is initialize method, right? That is initialize method here. Now I want to define for the string method. String method that means whenever I want to print it out the instant, I will have the what is the name, what is the name, what is the pin, and what's the balance here, right? Make sense? Okay, so that's what I see. I define the string method here. So it printed out what's the name. I take it out the name. What's printed out? What's the pin? What printed out? Take the pin here. And what's the balance? You have take it out. What's the balance here? So basically, for the saving account, you have the 3 attributes. You have the name. You have the pin and the balance. And whenever you generate the first time, whenever you generate the instant from this class, every instant has the balance 0 at the beginning. Right? Very good. Okay. Now for the saving account here, also I have some of the methods here. Get balance, that print it out. What is my current balance here? Get name, print it out. What's the name here? Get pin, print it out. What's the pin here? That's why I use it here. Pin, yeah. And I have the deposit. How much money, right? How much money you got it? So we just add it to the balance attribute here. Also for the withdrawal, right? In the case withdrawal, you have to check if the amount is less than 0, you cannot do it, right? And again, if the amount is greater than balance, you cannot do that. You have the insufficient fund here. Otherwise, you set minus it here. Okay, so the last, I think that's the last method here. You find out what is the interest. Interest is based on the rate here, right? So that's why you have interest here. Interest is the balance time with the rate here. And again, when you have interest, it automatically deposit into the balance, right? That's why you have the self deposit and interest. You deposit interest into the deposit here. Okay, so here's that's everything about the definition of the saving account. The definition of the saving account here. So we can see on this one saving account here. Okay, so that is the definition of the saving account. You see, I have the global constant. It's a 2% interest for everyone, right? Yeah, I have initializing method. I have string method. I have a get balance. Take it out. What's the balance? I have a get name. Take it out. What's the name? I have the get pin. Take it out. Pin. I have the method for deposit. Is that deposit? How much money you want here? You add it up to the balance. Withdraw also. Withdraw, you have to check if the amount less than 0, you cannot do it, right? And also, if the amount greater than the balance, you cannot do it here. Now, the last method, you have to compute the interest. Interest is based on what is your balance here. The time with the rate. And again, when you find out interest, it automatically deposit right into your balance. That's why I add it here. I add it into the balance. So in the program, what's the name program again? Okay, so, I don't know.
Banking?
Yeah, I think I have many transaction.
Oh, savings account.
Right. Now, saving account it is a module name where I create a class.
Oh, that's where you created the class.
No, I don't know.
Well, there's banking account.
We went over that last time.
Okay, I think this one. Okay,
No,
this one.
It doesn't have savings account though.
No, this one not correct. That this is the one you have to import it.
Yeah.
You have to import the saving account. Let's see. Oh my God, I have some. Yeah, one account. No, not this one.
No, that's just a module.
Yeah.
What about transactions version 1 and 2? Oh, there's savings account.
Yeah, import. Okay, that's I think that's one here. Yeah, you have the pin and start number here.
Mm-hmm.
And you have the saving account here. Now see, I store this one into the saving account, right? That's why I import it here. I import the saving account. It is class name, right? It's a class name from this one. Oh, yeah, from this one, class name. So for that one here, you got the name, right? You got the name, you got the pin, and you have starting balance. And now you generate the instant from the class name, the saving account here, right? So we see when I import saving account from module here, the later on when I create instant, I do not have to use the module name anymore, right? You do not have to use the module name. So for this one, you create a instant saving with the name of what you got here, with the pin of what you enter here, and the balance here. I balance. You can override for the 0 here, right? So see, now you have what is the pay? Now, so when you have the pay, you use the call it out the deposit method, right? You just add it up to your current balance, right? Now you bring the saving here. Again, the print saving is to call it out for the string method. We call it out is for the string method. In the string method, you have to print it out. What is the name? What is the pin? And what's the balance here? Right? Remember that whenever we use the print function and is the name, it will call for the method string. And in the method string, you print it out. What's the name? What's the pin? And what's the balance here? Okay. Now again, how much you want to withdraw? Like this one, how much you want to withdraw here? I take it out, and you call it out for the method withdraw here. Right? Call it out for the method withdraw. Again, update after you withdraw. What is your what is your updated balance here, right? And later on, you see when you have the deposit, when you have the withdrawal, and how much you can earn from interest, and you deposit it back into the balance. So we print out what is the balance after you got the interest. Make sense? So you see, that's a step of the program here. You got the name, you got the PIN number, and you got starting balance. So after you already have the three, you see, after you already have the three parameter here, name, PIN, and balance, you just generate instant. It's the name of the saving account. It's a class name. You have the three parameter, name, PIN, and start balance. Now after all, you see how much you can deposit, call it, and save it into the deposit. How much you want to withdraw, call the method withdraw, and you find out what is interest here, and call it for the status of the current balance. So think about, I have here, right? I have 1, 2, 3, 4. Now at the beginning I have 2,000 here. I have how much you paid for this one, 4,000. So see, for this one after I deposited here, right? 2,000 and 4,000. You see, you can choose step by step here. The first step, I generate the instant, right? The name here, the PIN number, and the balance. Starting here 2,000, right? Starting here 2,000. I think it should be better. I do it one more thing here. So you can change step by step here. Yeah. Do it again. Yeah, X. 1, 2, 3, 4. Now, starting balance 2,000 here. Oh, sorry. Why I copy this one? I copied the wrong one. Not this one. I want to print it. Yeah, I have to copy this one. Okay, so we print it out at the beginning. You see, when you have the print function here and the saving, it is the object name. I don't know that whenever you have the print function and object name, actually it will call it out for the. It will call it out for. It call it out where it call it out for the string method, right? And string method. That's why you print it out name here. Name here, I got X. All right. I have PIN here, 1, 2, 3. Balance here, 2,000. Okay. Now I got it again. And that's this one. Sorry. Okay, so that is the first print here. Now see, after you got how much you paid here, right? 4,000 here. It updated and printed out, right? So now you have name, PIN number, and balance. You add it to the balance, right? How much you withdraw here? 3,000 here. Again, it updates and print it out, right? So we have the balance here. I think again one more time. I think I should be one more. Yes, this one already. This one already, right? So after you withdraw 3,000, you have the balance 3,000, and now you have interest is a 60, and you add it to the balance. I see that's why at the beginning, sorry, at the end you have the 3,060 here. Okay, it makes sense. So it's quite simple program. Right? It's very easy. Have you to change that step by step here. Now, So basically, we learn about the object-oriented programming. You learn about the encapsulation. You learn about the abstraction. Now we learn about inheritance and polymorphism here. So inheritance is a process you inherit, and you inherit it from the in object-oriented. You can think about inherit from the from what is it? What's the name? You inherit from the upper class here.
You mean parent class?
Yeah, parent class here, right? So in the real world, many objects are the specialized version of more general objects, right? So think about, you have the example here, you have grasshopper and bees, they are specialized type of insects. So basically, it inherits every general characteristic of insect, right? But also you can have additional characteristics. Think about in the bee, they can have bumblebees, they're able to sting. That is method, right? And in the case of the grasshopper, it can jump here. So basically, all of them they share some of the common characteristics from the insect, but each of them they have a specific ability also. Okay, so in the case of inheritance, you can think about it is a relationship. It exists when one object is a specialized version of the another object. Specialized version. You can think about in the case of the bee and in the case of the grasshopper, they are specialized version of insect, right? And is a relationship here. Now, inheritance it's used to create a relationship between the class. Sorry, it's a super class, not parent class. Okay, it's my name. Yeah. So you have the super class. It is a base class. It's a general class. And you have the subclass or derived class. It's a specialized class. So in that case, you can think about here. Insect, you have the super class, right? And you have the bee and you have the grasshopper. They are subclass. So basically, it inherits every method and every attribute from the insect. But again, for each of them, they have specific method and attribute also. Okay, now think about very straightforward example here. Now think about, you need to create a class for car, picking up, truck, and SUV, right? So we think all of them, car, picking up truck, and SUV, all of them, they are automobile, right? So we can think about this here. Automobile here is super class, right? You have the super class here. So in the automobile, they have the make. It is a Honda or Toyota, whatever it is, right? You have the year model, you have mileage, and you have price, right? They are the attribute to the base class here or the super class here, right? So basically here, you just generate one super class. It is automobile, and in that you have the 4 attributes here. You have make, you have year model, you have mileage, and you have price. They are attribute to the base class here. Now, in addition, for each of the specific object here, of the specific class here, car, picking up, truck, and anywhere. Car, you have number of door. You have a 4-door or 2-door, whatever it is. Pickup truck, you have the dry tire, it's all-wheel drive or front drive or whatever it is. And SUV, you have the passenger capacity. Right? So now what happened here? In a class definition for the subclass, here, to indicate the inheritance, the superclass name is placed in the parentheses after the subclass name. I can think like this one here. You have seen, you want to define a class with the name car here. Now, if you want to inherit every attribute from the superclass, it's a make, year model, and mileage and price. You have to put it inside the parentheses after you define the class name here. Make sense? Make sense or not? Okay, and you can do the same. You can do the same with the other one here. And you can do the same. And if you want to define a class for pickup here, right? And also you have to put the superclass inside the parentheses here. And you do the same with the SDEV, right? So what happened here? What happened is that one. After you generate the class car and after you generate the pickup class here, it will inherit every attribute and every method from the super class here. Right? That's the first thing. Now later on, for each of the specific class here, you can generate your own class. You can add it to your own class here. Okay, so now see, you have initialize method. It's of the subclass called in the case of the initialize method here. Of the subclass, it will call the initialize the method of super class. Right? That's why you inherit everything from the super class. Then you initialize the unique data attribute of your own. Right? So in the case of car, you have a number of door. Right? In the case of the pickup truck, you have the type drive, and in the case of SUV, you have the number of passengers here. Right? So think about this one here. Now think about this one here. You can do this. You can look it on the chart here. You can see what happened here. That is a super class. That is a super class here. In that super class, you have the 4 attribute. You have make, you have model, you have minute, you have price. And in the case of that one, you have the init method here. You have init method. You have the set make, you have the set mode, and so on. Whatever it is, right? So we see in the init method, you take what the make, what the model, what the minute, and price here. So what happened here? When you define the class model, sorry, when you define the class with the name of car here, it will take it out every attribute and take it out every method from the super class. It will inherit it. It inherit. And again, for this one here, you see when the init for the init method here, you see it take it out the make, model, minute, price, but again, you can define your own attribute also. You can define your own attribute. In the case of car, it's a door, but in the case of truck, you have drive time, and in the case of the SUV, you have the passenger capacity here. Right? Okay. So we see that is the case. In the case inherited, you can reduce the code, right? You just define code for the one time here, but later on you can use it for many other class, and you can modify it. So now see, that is very straightforward example here. So you can think about this one here. Now that is a code when I define the class automobile here. Okay, if you look on the class automobile, you see you have the make, you have a model, you have mileage, and a price here. Again, you have the cell make, you assign, you are passing from the parameter here, and you do the same process, do the same process. And in the case of class, in the case of the automobile, it is a super class here. Yeah, I have all of the method here. I have all of the method here, right? I have you have the set make, the set model, set mileage, and set price. I get make, get model, get mileage, and get price here. Okay, so that is super class. That is a super class here. Now, what happens if I want to generate a class with a car here? You see, if I want to generate a class with a car, I use the name of the car, but I have to use a super class. I have to put it inside the parentheses here, right? So now what happened here? It has the definite initialize here. Now you see, initialize here, you inherit every attribute from the super class. And now you can add your own attribute, right? You can add your own attribute here at all. Now, what happened here? The first step, you have to call it out the method, initialize method from the super class. So after this one, actually, you got everything from like you got the model, you got the minute, and you got price. You inherit it from the super class. Now, your own, you can define what the number of dogs is. That's all, right? That's all. That's when you work with this one. And you see, again, you inherit every method from the super class, and now you only need to define your own method only, right? So in that case, you get a set the door, and you will get the door. Make sense? And you can do the same. You can do the same with the pickup chat method. You can do the same with pickup chat or SUV. So remember that something you have to remember when you define the class here. The first thing you have to put it. The first thing you have to put it the super class here inside the parentheses. That's the first thing. The second thing, when you define the initializer method here, you copy everything. You copy everything. You copy every attribute from the superclass. Now, the next step, you just add your own attribute here. And when you add all attribute, you inherit every attribute here from the superclass, and you have to set aside your own, initialize your own attribute here. Okay. And again, when you want to have the attribute here, you have to set door to take it number of door, and you have to get door to take it out. What's the number of door here? See how you run this program here. You have, I don't know if I have the program here or not. Yes, I automobile here, right? So see, that is step when you define the class name. It's a super class. It's automobile here. You have all of the 4 attributes, and you have many methods here. So okay, car, where the car? I think I have here car to move it. So see. I store into the automobile here, right? I store it into the automobile here. So why I import vehicle? Yeah, vehicle. It's not the same. So I think I have another module to go, right? Yes, this one. Why have so many? Okay. So this is module name vehicle here, right? I store it into the name vehicle here, and in that I define everything about the superclass automobile here. This one is a complete program already. This one is a complete program already. So I will have the car class here. Okay, so we see in the case I have the class car here. I inherit everything from that one. Okay, now that is class automobile, right? That is a class. That's a class automobile, and that is class car, and I inherit it from the automobile, and I store into the vehicle here. Now I have the demo here, right? First step, I import it from the vehicle. I import it from the module here. I define the main function. I have the car. I have the call. I have the call for the module name, right? And this last one, I take it out. The car here, it is a class. I define it in this module here. I take it out the car. And I initialize the name, the year. The model, the year, finish, and what is it? Price, and the number of door here. That's the number of door here. So I can take it out. I can take it out. What is the make? What is the model? What's the image? And what's the price? What's the number of door here for this one? So this is very simple. This is very simple example. But anyway, I hope you understand the process of the simple class and the subclass, right? You inherit everything from the simple class, and you can define your own attribute and your own method here. Okay, that is inheritance. Inheritance, that means you inherit. You just define one simple class, and you can inherit, and you can generate your own method and attribute. So now we will with I think it's a polymorphism. Polymorphism here. Polymorphism is now think about if you think in the previous class, right? Inheritance example show how to override the init method. Think about this one here. Think about how override here, right? You see, whenever you call the init method here, the first step you call the initial method from the simple class, right? And later on you can modify it by your own also with attribute. So actually this one here, this action here will override the initial method of the subclass here. Right? So basically the process here, we can do it to any method, not only about the initialized method. You can do it to any method. It's not only about initial method here. So think about this one here. That example here. I have the memo glass. It is a silver glass, right? In the silver glass here, and is that in my memo glass here? I have the cell and I have the species. That is what it can be, whatever it is, right? So in that case, I have the two method. I have the show method. It printed out what is specific key, and I have the define the mix up here. I have the every at the beginning, everyone is grouped. Every animal is grouped here. That's the sub here. So now what happened here? I create another class. It's a dog. Dog class is the subclass of the mammal, and that's why I put it here inside the parenthesis here. Now I do the same here, right? So I define the init and cell this one. I set it's a dog here. I set it's the guy here's a dog. Now you see, I define the make sound. You see what happened here? You can see what happened here. I do exactly the same method name, right? I do exactly the same method name. But you see, the action is that it's not the same. It's this one here, it overrides this one. So whatever it is, what happened here? Whenever I call cat or whenever I call the dolphin, whatever it is, they always go here, right? It inherit from the memo here. But whenever I call the dog, it will override this method here. Right? So that is a polymorphism. That means polymorphism is in the many form. You can define your own method in the same name, but when it will override the method from the silver class. Okay, so think about this one here. In that case, I have another example here. Where am I? Animal? Yes, animal here, right? So we see you have the one method in Excel. It applies in general for every animal, right? And I have animal example here. Outside, I import it, right? So I have the memo here. It's animal memo and regular memo, right? So in that case, I have the source species and I have the mix up here. You see, I am a regular memo, right? And you have the group here, whatever it is, or I can put it here, cut here, whatever it is, cut here. It means so. I'm a cast and dolphin, everyone have group. Now, what happened here? If I define class dog here, yeah, if dog equal to have to check out. No, I don't have the dog here. I have to define dog. Yeah. I have to define dog here. Dog here, right? So the class is the dog. So I do a class dog here. So I come back to the example. I have the animal. Dog. Dog. Let's see what's the dog. Dog. Yeah, dog. You do not have a. That's why I can put it here. And so we see we have dog. Sorry, dog. Show species. And dog. Let's start here. Okay, so see, whenever you do with any other animal, right? So we think about lion here. It only grew here. But whenever you call the dog, it up here, right? Because the thing, when you go to the dog, it has the same method here itself, but it overrides the same method in the simple classes. Okay.
Okay.
So that is a polymorphism. So basically, you are totally flexible with your own method in your own classes. So I think that's all for today. I think that's all for today.